Welcome to the presentation on the AIA Africa Consortium Education Strategy. My name is Greg Barret, and in today's presentation I'll be joined by Roy Forbes and Marcelo Ravai. The intention of this presentation is to provide you with an overview of efforts underway to significantly bolster learning programs for those in Africa. If you're not familiar with the AIA Africa Consortium, please take a look at the session by Lynn Morris and Barry Dorlatsky for an overview. In this session, I'll cover the general thinking behind the strategy. Roy will cover the efforts underway at Wits for the AIA Africa Consortium, and Marcelo will provide insight into his experience building and rolling out TinyML courseware. Our thinking is built around the following points: to significantly increase existing capacity to support students and faculty, rapid development and scalability of programs, strictly no reinventing the wheel, providing courseware to students that is world-class, the inclusion of universities where universities focus on value add, an approach of getting going by working with those who get it. Briefly expanding on each. To get out a few hundred top-notch persons in machine learning research and application across various disciplines in science, finance, legal and engineering in Africa requires feeding in a few 100,000 learners. Our objective is to reach over 100,000 students and faculty a year by working with MOOC providers and universities in the AIA Africa Consortium. To develop sufficient capacity requires establishing a pipeline that extends from short courses to undergraduate programs and ultimately to graduate programs and real-world application. We started with Coursera as Wits University, the lead institution behind the AIA Africa Consortium, already has an agreement with Coursera. Working with Coursera does not preclude working with other providers. Platforms like Coursera are tried and tested and currently support tens of millions of learners. Our strategy is vehemently opposed to any and all efforts that seek to consume scarce resources on building what already exists. Courseware development and maintenance is a costly and time-consuming exercise. Simply, if courseware is being developed, it must be novel and not duplicate what already has been done. Reference is an outstanding overview of widening access to machine learning with TinyML, which provides an example of what it takes to build and maintain a high-quality course. Given the cost of education and the availability of outstanding courseware, anything subpar cannot be justified to students. Feed them anything less and you can expect them to call you out. The path in data science, machine learning and deep learning space is well developed. Some examples that come to mind. There is introduction to statistical learning with applications in R. The Bloomberg Foundations of Machine Learning. Andrew Ng's Deep Learning AI courseware. Jan LeCun's Deep Learning course from NYU. Full Stack Deep Learning. TinyML. Fast AI. There is Open Data Science for All. You can pick a piece out of the machine learning stack, and there's free and open source courseware already available, even for the instruction set architecture. Even the Open Source Society University, offering a full education in computer science, with the courses themselves coming from persons at Harvard, Princeton, and MIT. It is a paradigm shift for many in academia who are accustomed to building courseware. Instead, leading universities have steadily been moving towards what is called the flipped classroom. A flipped classroom format means that learners watch videos and complete in-depth assignments and online quizzes at home, then come to class for discussion sections. The classes generally culminate in an open-ended final project, which the teaching team generally assists with. Such an approach enables universities to rapidly build capacity in machine learning research and application, and the universities can build their programs and courseware around these courses. This includes domain-specific materials, projects, and assignments as part of the flipped classroom format. There is no shortage of collaborations and opportunities for students and faculty on real-world projects, and our intention is to connect the pipeline of students and faculty to various efforts, including those within ML Commons, where current areas of work include data, best practices, inference, mobile, tiny, power, research, algorithms, medical, science, training, and benchmark infrastructure. From science to conservation, the opportunities for students and faculty are numerous to actually do meaningful, impactful work. This is actual AI for good. As a participant in TinyML 4D, we are moving forward with the rollout of TinyML in the African region. This includes eventually providing a curriculum for high school students. The recent announcement by UCT launching an online high school platform is an extremely encouraging precedent.
Hi everyone, my name is Dr. Roy Forbes and I'll be discussing a few of the efforts underway at Wits to host and manage the AIA Africa Consortium. The AIA Africa Consortium serves to create a network of researchers from both academia and industry hailing from all over the African continent as well as further afield, all of whom have a vested interest in the success and sustainability of CIRRUS. CIRRUS is a potential vehicle whereby the final report and recommendations of the Presidential Commission on the Fourth Industrial Revolution can be realized and implemented. In relation to our current discussion, one of the key findings of this report was that in order for our society to remain globally competitive, we would have to invest quite heavily in human capital development. The reasons for this are quite obvious, as developing a productive and competent workforce is crucial to helping the African region to participate not only in the Fourth Industrial Revolution, but to grow as a whole. Education is a crucial and important area of this development, and given the expanse of our continent, the use of remotely accessible educational platforms are quite necessary. Naturally then, in order to achieve this on a broad scale and in a reasonable time period, an effort such as this will require that we have access to a number of online resources, such as massive open online courses, or MOOCs as they are known. MOOCs can provide us with access to educational content that can reach a number of prospective students with little need for new infrastructure and also with minimal investment, since it will allow us to make use of features such as a flipped classroom format. A flipped classroom format is simply a pedagogical approach that moves instruction from a group learning space to an individual learning space, such as the kind which we're using right now during remote learning. An example of a platform such as this, the one which I will be discussing next on the few slides, is of course the well-known and well-established Coursera platform. As many of you know, Coursera is a platform that hosts a catalog of over 7,200 courses developed at universities and private institutions around the world. In fact, a simple keyword search of their catalog reveals that the site contains several thousand courses either directly dealing with or making use of some sort of data science component. And these courses span multiple disciplines and fields of applied and pure research. This course content is currently accessible and includes the necessary support measures and infrastructure that would allow a would-be student to enroll and start using the platform for learning, and they can do so almost immediately and with little infrastructure needed. So, should an instructor wish to add a machine learning module to an existing degree program on offer at the institution, they can do so using any of these already existing course materials. Additionally, the Coursera platform can also be used to develop custom assignments, assessments, and what are known as guided projects. Guided projects, for example, aim to provide students with job-relevant skills that they can make use of through an interactive experience that is guided by a subject matter expert. Finally, institutions can also generate revenue by having the novel course materials that they have developed added to the Coursera course catalog, thus providing further chance for reaching more students as well as providing an opportunity for revenue generation. So linking this back to our discussion, the AI Africa Consortium, we believe, is a good vehicle with which to adopt widespread use of online platforms such as Coursera, which would grant access to educational materials for as many students as possible. Many of the materials and learning programs that are available through the Coursera platform have been developed by subject matter experts and are of the highest level of quality in terms of both the content and the instructors. The large numbers of students that are enrolled in these courses are evidence enough of this. Take for example, as is shown on the left-hand side of the slide, the introductory machine learning course offered by Andrew Ng, which has over 4.3 million students enrolled at present, with many more having already completed the course. This is the type of content that we would like to provide access to for the AI Africa Consortium members. This is primarily because the use of platforms such as these provide us with an opportunity to reduce the cost of education by lowering the cost of course development and maintenance by leveraging existing course materials and infrastructure. It also allows us to focus on the value-add propositions presented by these platforms, such as the flipped classroom format and the guided projects provided by Coursera. Furthermore, by leveraging existing platforms, we can also significantly lower the cost of education per student through economies of scale, and also lower the cost of course deployment through the use of these MOOC platforms. Finally, the CIRRUS resource and infrastructure that are available within the AI Africa Consortium will complement many of these courses. This is because the courses mentioned here will feed in high quality faculty and students into some of the efforts that we have mentioned earlier. So at Wits, we're currently exploring exactly how this interaction may be formalized. The Coursera platform is currently being used for staff development at Wits University, and it is the intention to also provide the Wits student cohort with access to a Coursera for Campus license in the near future. With this in mind, we are seeking to develop a number of short courses to embed machine learning components in existing courses, and also to develop new course materials that are to be placed on the Coursera platform. These courses will be piloted within the university in the School of Chemistry. Chemistry as a subject is a good test bed for these concepts, as it contains numerous chemometric examples, particularly in signal processing. And these examples show that in time, chemistry as a subject will greatly benefit from the advancements in computing abilities that machine learning will provide. For the field of chemistry, as well as numerous others, adding existing content from the Coursera platform will help us to broaden the scope of the courses that we already have on offer. This will then also help us to attract and retain even more talented students, while also ensuring that these students are engaged in learning activities that involve the use of or the consumption of global content, which is much needed in order to maintain relevance and competitiveness, and which will ultimately ensure that our graduates are employable on a global scale. With these efforts in mind, we are therefore currently seeking to obtain a Coursera for Campus license, which the other members of the AI Africa Consortium can make use of in an identical manner. So, to reiterate, we are currently exploring options and seeking funding that would help us to obtain a Coursera for Campus license for the exclusive use of the AI Africa Consortium. In doing so, and by making full use of the capabilities offered by the Coursera platform, we believe that we can ensure that we will have rapid uptake of a large number of students spanning multiple disciplines from institutions across the African continent. We will also be able to make use of the Coursera platform to create and host course content that can be tailored to region-specific research and development challenges and social issues. Furthermore, we can also make use of the Coursera platform to introduce a larger number of African researchers and research students to the fields of machine learning and artificial intelligence, and also allow them to upskill and incorporate data science practices to enhance their existing research activities, which can aid them ultimately in developing and innovating around their own research ideas and interests.
Hello, everyone. I'm here to talk about TNML, embedded machine learning, and our educational experience in Brazil regarding this subject. Who I am? I'm Marcelo Rovai, and I'm an engineer. I'm a Brazilian, living in Chile nowadays. I'm a master in data science, like data science for UDD Chile, and a volunteer professor at UNIFE, Federal University of Tejubá, where I'm teaching the first TNML course for engineering undergrad students in Latin America. But first of all, what is machine learning? What's TNML? Well, TNML is a fast growing field of machine learning, something brand new, where we are mixing three great areas, three major areas of interest, like algorithms, hardware, and software. So it's a novelty, and and together bring a lot of challenges for us professors. Well, the important thing about TNML is that we have machine learning. It's part of artificial intelligence running on device, running exactly what the things are happen. It's in the connected to the physical world. That's very interesting. And the big challenge that we have is that machine learning works with a very small amount of power with small batteries, and in devices with only few kilobytes of memory. This is the big challenge. Besides all the challenge that we can have with such kind of applications in very tiny devices, we are we are it's possible to find machine learning TNML applications everywhere nowadays, like personal assistant that we can see in our home as Alexa, Hey Google, in Office to turn on, turn off lights automatically, to to see if a people is a person is there to when you press a button to the elevator, or use your voice to call elevators, doing using both two types of algorithms with audio and vision. In industry with anomaly detection, we can prevent if a machine is running with a problem or not. But not long only let's say it's not only with the simple devices we can find TNML. Nowadays TNML can be found in for example, in several areas in the industry, and more important, we can find in health industry, in animal sensing. We are seeing today such kind of devices helping to protect elephants in Africa. We are seeing this type of devices using in very small very small teeny equipments, like smart watches, when you can see if how is your heart is doing, or small devices in your brain. Or here, for example, you can see it's a great project when the researchers in Africa is trying to predict in cholera in rural communal tap waters. It's fantastic. Okay, so facing all the challenge regarding TNML, regarding develop machine learning that's part of artificial intelligence in very thin devices, with very small amount of memory, it's a lot of challenge. So how we teach that? Well, having a very good starting point, that was what have been developed in Harvard Engineering School by Professor VJ, and after, and the mock course in EDX, when they teach all the TNML applications and the deployment in TNML devices. We start from that experience, plus what have been developed by Edge Impulse, and one of the lead companies in the industry of TNML development. So we put both together and try to teach the students. So we start with the first part of the course, focus in what is Python, Jupyter Notebook, etc., and all the fundamentals of TNML. But in that part, the students could understand how to use frameworks like TensorFlow, how to they create models, how to work to deal with data sets, to clean data sets, to understand the data, to run the models, to deploy the models inside their computers, or mainly using tools like a Colab from Google. Second, what we did was, once the students have all the knowledge or the basis about the frameworks that we use in machine learning in general, not talking really about TNML, but more in general, we start really going deep what means to develop application in TNML world. All the steps that must be followed. And the Edge Impulse Studio was very important for us in this moment, because they help the students to very quickly to understand how to capture real data using their cell phones. They using the normal cell phones, the regular smartphones. They use the accelerometer and the microphone inside the cell phones to capture real data, pre-process the data, generate models that they have learned in the first part of the course, correct, and to deploy in the same cell phone. All that knowledge, we could really go into the end of the most important part of the course, that was how we can have that model developed, in a bigger machine, and shrink the code in order that we can put that code inside very, very, very small devices. And we did this. And the important was the students really, make using their hands, have their hands dirty, with the data, with with bits and bytes, that you can have when the students could develop several types of different applications, word detections, like OK Google or Alexa, or vision projects where detecting if a person has a mask or not a mask, if a person is not a person, movements, etc. That the students could really do these during the course. To do that, we use a kit, a fantastic kit that was developed by Arduino, Harvard people, Google people, specifically for the EDX mock TNML course, that we also use it in our course at the Unify. So what we did, we the kits from Italy, receive it to university, we package everything. Because the COVID, the students was in their homes, they were not at the university. So we send the kits to the students. The students could do laboratories, in parallel with the lectures, that the weekly lectures that they have. So they could experiment, they could test, they could exchange ideas among them. They could develop a final project, a very interesting project regarding TNML. And including the university, what they did, they when they sent the kits, everything was prepared for the student. At the end, at the end of the course that was now, the students put back in the back in the kits in the package, the original package, the original box, and everything was paid for them to by mail deliver the kit back to the university, so the university can send now for the second the course that we will have in the next semester. But better than me to talk about that, let's see what one of our best students, Stephanie, can say about.
Hello everyone, I'm Stephanie Coimbra and I'm a student of computer engineering at the Unifei Itajubá, Brazil. I'm also doing the TinyML course. So it's an area that is growing so fast, and it's extraordinary what we can do with that. I fell in love with this AI field, so I certainly will use that on my career. About the requisites to do the course, I had a solid base on statistics and hardware in general, but the university helps to bring closer to us the opportunity to work with machine learning. And with the kit and the material provided by our Professor Marcelo, it's been a great experience. That's the kit that was sent to our homes. So we have here an Arduino BLE Sense, a camera, and also a cable to write the code. So it's pretty amazing, right? I felt a need for deeper knowledge in the Python programming language as I didn't have a good contact with it, but I managed to study on my own and was more than enough to follow the project and the course. So let's continue to make things happen through the world.
Thanks, Stephanie. She's an amazing student. Yeah, really good. Well, regarding the course was delivered during 15 weeks. With a weekly lectures where the students could learn the theory and also to test or to try to code during the class with me. And after every class, they received a kind of a quiz, in their homes to verify what if they have learned it or not. So together with an additional readings, some codes that they have to develop, some notebooks with some projects like models to be developed, trained, etc. They need to deliver everything of that for a grade for the course. The students they were grouped together, and 3 or 4 students each, and developed several projects. It was very nice projects, like a COVID detection with cough, fire detection using image, mask or not mask detection, if the movements are correct and during the exercise, physical exercise, etc. So it was really a success, and the students love it to do that. As we said before, and also the Stephanie comment with that, because we have students for 3 main areas of the university for the computer or the computer engineering, from control automation, electronics. We have different backgrounds, and as Stephanie comments, for example, she didn't know she knew only a little bit about the microprocessors and very few about Python, for example. And we have 1/3 of the students that have very low knowledge about Arduino, for example, and a lot of students didn't know Python. Half of the students never learned about Python, and the other half never heard about, or very few heard about, for example, TensorFlow. Okay, so that was a big challenge. We have students where the great majority they didn't know TensorFlow or machine learning, what I'm talking about, and the 1/3 of the students didn't know about microprocessors. Okay, so we put all together. We need to, was a challenge to balance that, and what have been developed by because again, this is the base of this, was what have been developed by Harvard in the Harvard X course, TML course, was very helpful. And when we did the post-course survey, we could realize that the students here, they have it was very, very clear for them that they have a very poor knowledge about the subjects. But at the end of the course, the great majority, I can say 80% of the students, was very pleased with what they have learned, and they are preparing to continue to learn more. So this was key. And what we are doing now is trying to send this kind of knowledge everywhere in the world. I'm part of an initiative, that is led by Dr. Marco Zenaro in the ICTP in Italy, is the TinyML4D. This is an amazing initiative, to spread the knowledge or the education of TinyML everywhere in the developing world. So, for example, for the first phase of our project, we have selected 20 universities from, more than 16 countries, in Latin America, in Africa, in Asia, that will participate in our first seminar in November. We're talking about TinyML. The idea is to replicate what we did, not of course in a 15 weeks course, but in a very focused, use the same kit that we use in the course here in Brazil, to teach students all over the world. But most important, to have a solid network, academic network, to exchange projects among those countries. This is our goal, okay? And we are, we starting this year with a lot of initiatives. We are doing, have lectures in Brazil. We start to have lectures in Latin America. I'm here talking with you in Africa, and that's our future. Have TNML, machine learning apply to very thin devices, to embedded devices all over the world. This is the future. You know, if the IoT, could took the information from billions of devices, and send to the cloud, let's say, to process their data, we're doing with the TNML is took all that information, and using at the same place where the data is generated to create knowledge there in that part. Thanks a lot and stay safe. Bye.